Dear all, I would like to welcome you the third part of question paper discussion of sub-engineer examination. Moving on to the discussion, initially I would like to show you what are the question I am going to discuss, which is already repeated. Okay, question number 31. You can go through that. So likewise, I will be scrolling down. So kindly pause the video and note down the right answer. Fine. So I think all the questions are familiar. You can go through the particular questions and find out the right answer. It will be helpful once I'm going to discuss individually. Okay. So you can go through the question. Pause if you want to work out for a while. Yes. These are the questions. Around 16 questions, there are 15 questions are there. Kindly go through that and note down accordingly. Moving on to the discussion. Let us discuss the individual question. So the first question is a Swinburne's test of DC machine. The shunt machine is run as. What are the options? Motor at full load, generator at full load, motor at no load, generator at no load. Basically, Swinburne's test is used to predetermine the efficiency and regulation of DC motor. What kind of DC motor we are going to use for Swinburne's test? We require DC shunt motor. Is it a load test or no load test? Yes, it's a no load test only. Our ultimate goal is to predetermine the efficiency. That is the main purpose of Swinburne's test. So we can go for, based on the 3 or 4 options, the best answer is motor at no load. Kindly select option C. I think the answer is clear to everybody. So you have to discuss something about Swinburne's test, wherever it is used, why it is required. Those important points you have to keep in your mind. Next is the voltage equation for a long shunt compound wound motor is given by, which is the right answer. So if I talk about the compound wound motor, definitely it must have one field, okay, field winding. 2 field winding will be there. So one will be series to the armature. Am I right or not? So this is actually your long shunt DC generator. Okay, so we are providing the supply voltage. V is the supply voltage, right? Fine. Then we have the input, and this is your back EMF, which will be opposite to that of the terminal voltage. This is your series field. We write it as RSC, and we can write the shunt field as RSH. Correct. So this is regarding your long shunt compound motor. So we can write, so whenever you are talking about the resistance, it is a combination of RA plus RSC. So we have to talk about, this is your armature resistance and this is your series field. So when it comes to the compound wound motor, long shunt compound wound motor, then it becomes like V is equal to EB plus IA into RA plus RSC. So we can go ahead with the option B. Option B is the correct answer. So when it comes to short shunt, then you could have selected option D if I talk about the short shunt. But I'll be talking about long shunt only. Fine. So please go through what is compound wound motor, what is back EMF, the significance of back EMF, what is the relation between terminal voltage and back EMF. Those things are important. Now I would like to discuss about question number 33. DC series motor is best suited for, which is the right application? Traction, then pumps, fan, none of this. Usually, DC series motor is a variable speed motor, which has high starting torque and which is most convenient for traction application. Right now, these kind of motors are replaced with the induction motors because DC motors are not convenient, not economic, not economic concern. It is not maintenance will be totally difficult and it is not real convenient. So that all the type of DC motors are replaced with the induction motor. Similarly, I would like to give some list of motors which will be helpful for various applications. Okay, you can go through that. For your mixer grinder, normally we are using universal motor. Okay, it is similar to DC series motor. It is applicable. It works based on AC supply. Basically it works based on AC and DC. Universal motor. Okay. mixer grinder. Fine. Similarly, in your ceiling fan, you are using the induction motor. It's capacity-based, capacitive start type induction motor. Okay, it's a single-phase induction motor. It works based on the double field revolving theory. So there is a two field which is going to generate. Also, it is not a self-starting device, so we are using capacitor. For the lathe machine, the shunt motor is DC shunt motor is more preferred. Why? Because we need a constant speed machine. Similarly, for the lift, it is better to go for series motor. Fine. So these are the different applications concerning for different type of motor. So moving on to the question number 34, the advantages of corona effect. Okay, you must have studied about corona, how the corona is forming, because it is related to one of the high voltage engineering phenomenon. See, there are two conductors. If the voltage is uh, exceeded more than that of the threshold voltage, the medium become conductive between the two conductors. Same thing is happening in case of HV transmission lines. Suppose two conductors, suppose the distance is if the applied voltage, if the voltage level is too high, then the surrounding medium is becoming conductive. That phenomenon is called as corona. I have done a detailed video on corona in the high voltage engineering playlist. You can go through that. If necessary, I will share the particular video in the I button. So effect of corona are hissing sound, then violet glows. You must have familiar. So the advantages of corona. See, the main advantages. So the effect of transient, which is produced by the lightning surges and other causes are minimized. That is a major benefit of corona. So this is because of the main advantage, the corona effect, that will work as a safety valve for the surge arrestor. That is a major advantages. So we can say that the works as a safety valve for surges during lightning and thundering. It will protect the devices against the lightning surges. So we can, due to the corona effect, okay, it will act as a safety valve for the surges. Fine. So that is the main advantages of corona. So this is very important. The phenomenon of rise in, another question, phenomenon of rise in voltage at receiving end of the open circuited or light loaded condition, that is called a Ferranti effect. So due to the Ferranti effect, because there are certain amount of capacitance which is present inside the transmission line, because of that, sending and receiving end voltage exceeds the sending end voltage. This effect is known as Ferranti effect. Fine. Now question number 36. The insulation of modern extra high voltage line is designed based on lighting voltage, corona, EMI, switching surges. Which would be the right answer? Just check it up. So if you find any of the term like a voltage level, design of voltage, it is directly related to insulation. Based on the insulation only, the voltage level will be decided. Similarly, how to decide the size of the conductor based on the current rating. So voltage rating will be directly related to insulation. So from this option, we can say that switching voltage. See, I have told you the term voltage. Voltage that will be dependent on that will be directly depending on the insulation level. So it is better to go for option D, switching voltages. Okay. So when it comes to the insulation, you have to take care of the parameter of voltage. When it comes to the size of the conductor, you have to take care of the current level. Question number 37. In circuit breaker, the contact space is ionized by field emission from the contact surface, then the thermal emission from the contact surface, thermal ionization of gases, any one of the above. So you can go ahead with any one of the above. That is the right answer. So question number 37 is fine for everybody. So you need to understand the circuit breaker, how does it work, what is fixed contact, what is moving contact, what are the types of circuit breaker, all the information, it is making capacity, breaking capacity. So try to collect those details. So another important question, especially in the sub-engineer examination, the IS code for the practice earthing, which is the right answer, IS code. So there are different type of IS code you need to maintain. Especially if I talk about earthing, you need to follow the IS 3043. So you have to remember this. Similarly, there are different IS codes. IS code for practicing, like steel plate for pressure vessels, that you can go for IS 2041. This is the right answer. I will repeat again. The code I am going to recite once again. The steel plate for pressure vessels at moderate low temperature. That is basically IS 2041. For electrical wiring installation, you can go for IS 732. Why I am not mentioning IS 8081? Because this is related to construction, especially civil engineering, civil department. So from this, which is the right answer, you can tell me. So here, the earthing, for earthing, you have to go for IS 3043. This is very important. Fine. You have to bifurcate all the code, different type of codes. You can expect it. Okay, you can expect this kind of questions in the competitive examination. So another important term is called AMF panel. What is AMF panel? Can you identify the answer? AMF panel. Just cross check once again. So AMF means auto main failure. That is the right answer. Auto main failure is the right answer. You can elaborate AMF. Auto main C. Option C is the right answer. Go ahead with option C. Now I am going to proceed with another question. Which of the following area is preferred for solar plants? Coastal area, hot arid zone, mountain tops, high rainfall zone. Obviously, without thinking much, you can go for option D, hot and arid zone, because sunlight is very important wherever it is available. Okay, you can install solar plant. So another question, disadvantages of renewable energy sources, which is the right answer? See, intermittency, availability of low energy density, lack of dependability, all of the above. It is better to go for all of the above because these are the setbacks or shortfalls of shortcomings of renewable energy sources. So it's a simple question only. So another important question, iron core in the transformer provides dash path to the main flux. So transformer comprises of core and winding. The purpose of core is to move, it is support for the movement of flux. Okay. Also the features of the particular core that will the transformer provides dash path to the main flux. It ensures low reluctance path. What is a reluctance? Reluctance is nothing but it is a opposition. It is a property of a material to oppose the magnetic flux. That is called a reluctance. So the right answer for the question is purpose of iron core in the transformer is to provide low reluctance path. That is the right answer. I think you will select option A. Option A is the correct answer. Moving on to another important question. The negative voltage regulation of the transformer is possible only with the dash load. This is very important. So what is voltage regulation? Percentage voltage regulation. So let us write V regulation. That is given by no load voltage minus full load voltage divided by full load voltage. Okay, this is called voltage regulation, which will be multiplied with 100. You will be getting in terms of percentage. Here, if the voltage regulation is positive, suppose if the voltage regulation is positive, then the power factor of the load will be always lagging. Positive voltage regulation. If it is positive, then power factor will be lagging power factor. If the voltage regulation is negative, power it's for leading power factor. Now you tell me, I told you that for positive voltage regulation, the load power factor is lagging. Therefore, for this case, you need to select the inductive load. Okay, for negative, if the voltage regulation is negative, then power factor of the load will be leading power factor. That is applicable for capacitive load. So here you can tell me which is the right answer. The right answer will be option A. If the negative voltage regulation implies it is applicable. If the voltage regulation is negative, sorry. If the voltage regulation is negative, the question, if the voltage regulation is negative, the right answer is, which is the right answer? You can go for the capacity. Correct, no? Capacity. So capacitive load. This will be capacity load. Why? Because voltage regulation is negative. B is the right answer. So go for the option B. Option B is the correct answer. Okay. So let me rub the screen. You have to understand what is voltage regulation. Then for inductive load, voltage regulation will be positive. Capacitive load, voltage regulation will be negative. So another important numerical example, a 2 kVA transformer has iron loss of 150 watts and the copper loss of 250 watts. Maximum efficiency of the transformer would occur when the total load losses. So we can write a total W total. W total is equal to iron loss. let us write Wi plus a fraction of load x square into WC. WCU. Wi is nothing but iron loss. X is the fraction of load. WCU means copper loss. How to calculate x? X square. X square is nothing but it is a ratio of iron loss divided by copper loss. Fine. Wi divided by WCU. So what is W iron loss? Iron loss is 150, right? 150 divided by what is copper loss? 250, right? 250. So 0 get cancelled. It becomes 3 by 5. Now total loss we can calculate it. WT is equal to iron loss is how much? 150, correct? 150 plus 3 by 5 into copper loss. What is copper loss? 250, correct? No? 250. So 5, it becomes 150 plus 50 times 350. 3 into 50 means 150. 150 plus 150 is nothing but 300. I think it's clear to everybody. Yes. So go for option C. Simple calculation. It is very easy only. For understand the formula. This is a general formula. Fine. X is the fraction of load. You will be getting 300 watts. Okay, fine. So this is actually the way how to solve this problem. Very important. I have seen several type of questions in SSC examination also. So this may expect in future. You can focus more, try to solve similar kind of problems. An alternator driven by the steam turbine is called, which is the right answer. For steam turbine, it is turbo alternator, turbo alternator. Okay. It's a non-salient pole type alternator. For salient pole type alternator, it can be used for hydro. There are two type of alternator, non-salient pole type alternator and the salient pole type alternator. Salient pole type alternator is suitable for low speed application, where non-salient pole type alternator is suitable for high speed application. For steam turbine, high speed is required. Okay, for steam turbine, usually we go for turbo type alternator. So next one is, in a single phase induction motor, the starting torque is. So you have to apply the double field revolving theory. If I talk about the single phase induction motor, obviously the starting torque is net starting torque is 0, because there are two forces. One is left side, another will be right side. Like you have to apply the double field revolving theory. The net torque will become 0 only. That is why we can say that say induction motor, single phase induction motor is a non-self-starting device, where three-phase induction motor is a self-starting device. That we can surely say. So remaining part I will be continuing in the last part, that is part 4. So anyway, if you are having any queries, please put up in the comment box. I'm very happy to answer that. Prepare very well for your examination. I wish you all the best. Thank you for watching this video.